Rust 1.72.0 was released today, August 24th, 2023. What do we have today? Number 1. Compiler errors now know about items that have been config-disabled based on a feature. In the past, if you used a config attribute to conditionally enable some code, then the compiler didn't know about the item when the feature wasn't specified, which led to confusing compiler error messages. The classic example of this is when you try to use Serday for the first time. Just about every tutorial out there, including Serday's own, starts off telling you to derive serialize for a struct. But the serialize derive macro is conditionally enabled by the Serday derive feature flag, which if you look at the feature list for Serday, you will see is disabled by default, which means that you used to get a confusing error about not being able to find something that should clearly be there according to the documentation. Now you get a note about an item that was configured out and another note about the feature that the item is gated behind, so you can go enable that feature and move on with your life. Number 2. Before this release, Rust had a hard-coded maximum limit of statements that it would run as part of Const evaluation. That means when Rust was evaluating Const expressions at compile time, it would only do a certain amount of work before it would error out. This was intended to combat infinite loops that were hit during Const evaluation. But it turns out that there's a lot of complicated things people want to compute at compile time, and this has been an obstacle for them. So now that hard-coded limit has been changed to a deny by default lint. If you hit it with your code, you can just allow the lint and unleash the power of unlimited time for Const evaluation. Number 3. Public service announcement. If you compile Rust code on or for Windows 7, 8, or 8.1, support for it is ending soon. Not in this release. This release supports Windows 7 and above, as does Rust 1.73 in October, 1.74 in November, and 1.75 in December. But starting with Rust 1.76 in February of 2024, only Windows 10 and above will be supported as a compilation host or target, unless someone goes and does the work to re-add older Windows support as a Tier 2 platform. That's always possible, but Tier 1 support is going away for sure. Number 4. If you are using a 64-bit Lunxen processor, good news, inline assembly has now been stabilized. Have fun storming the castle, boys. Number 5. Some import ambiguity errors were eliminated. For example, in this code, we have a struct s at module scope and a struct s shadowing it in the main function scope. If we try to import s and alias it to a different name, we get an error about s being ambiguous. But it totally isn't. If we try to create an s, the compiler knows we should use the s from the innermost scope. In 1.72, the use statement works the same way instead of causing an error. Number 6. The first bit of native WASM exception support has landed. However, the standard library has not yet been adapted to support it, and there are a couple of rough edges. But if you want to try it, here are the flags you need to pass to rustc to enable it. I'm always excited to see progress on the WebAssembly front. Number 7. 3 new Tier 3 platforms have been added to the platform support. The first 2 are more Lunxen targets. Obviously, somebody out there is having some fun with this RISC processor. The other is NetBSD on big endian ARM64 processors. Number 8. ThreadSanitizer support has been enabled for Solaris and Illumos targets. ThreadSanitizer is a race detection tool. For more information about it, see the link in the details. Number 9. BufReader, BufWriter, and LineWriter all had implicit sized bounds on their generic type parameter. This has now been relaxed to be only possibly sized. This means you can, for example, use a trait object with these structs now, which should be a bit more convenient in some situations. Number 10. Before now, if you attempted to kill a process that had already ended, an error would be returned. Now, an OK is returned under these conditions because it's probably okay that a process is dead if you're trying to kill it. Number 11. PartialOrd, the trait used to compare whether an item is bigger or smaller than another, has been implemented for Vecs that use different allocators. That's cool. Number 12. Every type in Rust gets a TypeId with a hash that ought to be unique. The number of bits for this hash was increased from 64 to 128 bits to drastically decrease the chances of any 2 of these hashes colliding. This should be great for projects with complicated reflection stuff like Tokyo or Bevy. Number 13. If an arc, RC, or weak was wrapping a trait object, then the pointer equal method would return false if the type of the two trait objects were different, even if the data being pointed to was the same. This has been fixed. Number 14. There have been a few good Rustdoc improvements. First, Whitespace in search input is now treated like a path separator. To get these results before, instead of vec space push, you would have needed to type vec : push. This is much nicer. Second, item types are now listed in the search results explicitly. Before this, you could only infer the item type sometimes by the color of the HTML link. Third, did you know that you could search for function and method signatures by specifying input types, then the return arrow, and then output types? Apparently this is a thing, and I am one of today's lucky 10,000 to learn about it. Anyway, this search syntax now supports searching for arrays and slices using square brackets. Empty square brackets mean a generic slice or array, and putting a type inside of the square brackets means a slice or array of that specific type. Number 15. The Zdoctest-in-workspace flag is now enabled by default. This just means that when documentation tests are run across an entire workspace, the working directory is set to the package that the doc test belongs to when it is run, making it so that any external files a test tries to reference are in the same relative position no matter what directory you're in when you start running all the tests across the workspace. Number 16. 4 clippy lints were uplifted into Rust itself. The first one is undropped manually drops. This is a lint that warns you if you try to use standard mem drop to drop something wrapped in the manually dropped struct. This won't drop the wrapped value because the whole point of the manually drop struct is to make it so that you have to call one of its methods to drop the value it wraps. The second lint, invalid UTF-8 in unchecked, was split into 2 separate lints when it was uplifted. The first one, I've numbered 2A, is invalid from UTF-8 unchecked, which emits an error lint when you try to pass an invalid UTF-8 literal to stir from UTF-8 unchecked, because that would be undefined behavior. The second lint split off from this one, I have numbered 2B, is invalid from UTF-8. This emits a warning lint when you pass invalid UTF-8 to the stir from UTF-8 function. This one is only a warning because the program will safely crash when this happens, unlike the undefined behavior from the last one. The third lint uplifted is castRef to mute, which emits an error when you use unsafe Rust to cast an immutable reference to a mutable reference without using interior mutability, which would cause undefined behavior, and Rust does not like undefined behavior. The fourth and last lint uplifted today is invalid not a number comparisons. The very reason that floating point numbers cannot implement the equality trait is that the not a number value is literally not equal to anything, not even itself. So if you try to compare not a number to anything, it will always be false, so this lint will warn you about that. Number 17, stabilized APIs. There are just a few this time, let's go over them. The first is that there is a blanket sync trait implementation for MPSC sender if the type it is sending implements the send trait. The next is that borrowed string slices now implement try from a borrowed OS stir. And finally, the string leak method leaks the buffer a string is using, which is usually used to promote the lifetime of a string to tick static, similar to box leak. Number 18. There are 4 items which are now available to use during that unlimited const evaluation time you now have access to. All 4 deal with the cstir struct. From bytes with null creates a cstir from a byte slice with a null terminator. 2 bytes converts a cstir into a byte slice. 2 bytes with null converts the cstir to a byte slice with the trailing null byte, and toStir returns a borrowed string slice if the cstir happens to contain valid UTF-8, otherwise it returns an error. Number 19. Feature names must now be only letters, numbers, and underscores. This is to resolve security issues such as CVE 2023-40030, where, apparently, you could use JavaScript code as your feature name, and then if you ran cargo build -- timings, the generated HTML report would contain the JavaScript code which would run when you opened it in a browser. I have to admit, it never occurred to me that you could use arbitrary code as a feature name anyway, but now you can't. Number 20, and I think this is the first time I've reached 20 items in my coverage of Rust releases. Cargo now warns you when your workspace config hasn't explicitly set a resolver version. This is super helpful because even though normal projects have been using Resolver 2 by default since the 2021 edition was released, workspaces still default to Resolver 1 unless you explicitly enable Resolver 2. Number 21, there are 24 new lints. Are you ready for this? Number 1, manually try fold checks to see if you're using the fold iterator adapter and then using the try or question mark operator inside of it. Instead, use the try fold iterator adapter, which is more idiomatic and probably faster. 2, tuple array conversions. Instead of manually converting a tuple into an array, consider just calling into to get the job done because Rust can do that for you. This lint is in the nursery, meaning that you will have to enable nursery lints in order to see this one. 3. Redundant at rest pattern. Using square brackets, slice name, @ symbol, and range operator syntax to match on a slice of an entire vector is a bit overkill. Just match the whole vector and be done with it. 4. Needless pub self. Pub self is defined to be a no-op. It literally changes nothing. So why bother typing it? 5. Pub with shorthand. This is another nursery lint you have to opt into. In fact, let's combine it with the number 6, pub without shorthand. These are provided just in case you want to enable one of them to make sure all of your pub declarations either do or don't use the optional in keyword. I personally feel like this one is reaching a bit. 7. Manual range patterns checks to see if you are manually defining a range and prompts you to use an actual range instead. 8. Needless rostering hashes warns if you are using more hashes on your rostering than necessary. In most cases, one hash is enough. 9. Needless rosterings warns you if you are using a rostering for no reason. 10. Incorrect clone impl on copy type checks to make sure that a manual implementation of clone for a copy type dereferences self like it is supposed to. 11. Drain collect checks for a full drain followed by a collect and recommends calling memtake instead. 12. Single range in vec init checks for a vec or an array that was initialized with a range. This will place a single range struct inside the vec or array, which is probably not what the programmer intended. Instead, use collect on a range to initialize a vec, or use the array's semicolon length notation. 13. Unnecessary literal unwrap warns you if you wrapped a literal value in an option or a result and then just unwrapped it again. If you just want the literal, just use the literal directly. 14. Large stack frames checks to see if you are allocating large amounts of data on the stack. The main culprit here is typically arrays, since arrays in Rust are allocated on the stack by default. Getting arrays allocated on the heap is slightly awkward at the moment. The way to do it is to create a vec first, which always creates an array on the heap as its backing storage, and then call into boxed slice to get the boxed array back out. 15. Min ident chars checks for identifiers that are just a single letter. You have to opt into this lint because single letters are often just fine for a 3-line loop. But if you're traumatized from Go's recommendation to use single letter variable names instead of self, feel free to enable this lint to prevent such shady practices. 16. Needless if warns you if you are using an if expression with an empty branch block. Just remove the unnecessary if. 17. Excessive nesting warns you about, well, excessive nesting and nudges you to refactor your code so it isn't so nested. 18. Arc with non-send sync warns you when you have an arc wrapping a type that doesn't implement send or sync. Either you should make your type implement send and sync, or you should just be using an RC instead of an arc. 19. Redundant type annotations is another opt-in lint that warns you about type annotations you don't strictly need because the compiler can figure it out. All right, now 20, 21, and 22 are all opt-in lints that just warn you if you use specific methods for converting bytes to or from native endian, little endian, or big endian respectively. I have no idea why you would want to enable any of these lints. If you know why, please comment below and clue me in. 23. Pointer cast constness is a lint you can opt into that looks for when you manually cast raw pointers between const and mute and recommends using the methods that do the same thing while protecting you from accidentally casting to another type. This could be a useful lint if you're dealing with a lot of FFI and pointer casting. And number 24, needless else warns you to remove your else branch if your else branch is empty. And that is the end of the new lints. If you're going to RustConf in September, sign up for my Ultimate Rust Crash course through the RustConf website. Or for any of my independent courses, tutoring hours, or events, sign up at agileperception.com. Links are in the details below. Like and subscribe if you want more videos like this.